Well, I'm probably on my way to Long Beach, California right now, and hopefully you guys are having a great day. Topic today is graphing, quadratics, in standard form. The book likes to call it quadratic form, so we'll call it quadratic form also, okay? Okay, so quadratic form, actually the name comes from the quadratic formula, which we won't do today. But if it's in the form of some number ax squared plus bx plus c, which is different than what we had yesterday. Yesterday we had it in vertex form. Then you can still graph it. Granted, you can do an awful lot on the calculator, but we want to learn how to do it by hand because we're going to hit some story problems here pretty soon. We're going to have to know how to do it this way. Okay, so first of all, the vertex. Hopefully you read that the vertex, the easiest way to find vertex is with this equation, x equals negative b over 2a. All right, a, b, c. All right, so in this case, a would have to be 1. Oops, a is 1, sorry about that. A is 1, and b is negative 2. So let's find out what the vertex is. So the vertex, we're going to go ahead and put as x equals negative b, which is a negative 2, over a 2 times a, which is 1, which of course is 2 over 2, 2 over 2, right? 2 over 2, which is 1. So that's the x value of the vertex. So all we know so far is the vertex is 1 something. Well, to get the corresponding y value, that's easy. All we're going to do is take and plug that value into the original equation. So let's take this x value, let's plug it into the original value. So for x. So to find the corresponding y value, we'll go y equals a 1 squared minus a 2 times 1 minus 8. Let's see, that's 1. There's the bell. 1 minus 2 minus 8, which makes a negative 9. So I'll have y equals negative 9. Okay, so we have a vertex at 1, negative 9. So let's find that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. Now, one of the things I know is for sure the parabola is going to open up because a is positive. So if a is positive, which it is, because a is a positive 1, it will open up, which means we'll have a minimum. This will definitely be a minimum. So my minimum value is at 1, negative 9. Also, what I know about the parabola is the fact that it is symmetrical, and it's always going to be symmetrical with its vertex. So it's got a line of symmetry that goes straight up in here. Now, a line of symmetry is a straight down vertical line. It has an equation, but because it's not a function, it has to have a weird equation. Its equation is just simply x equals, in this case, 1. That's the equation of the line of symmetry. The line of symmetry is this equation, x equals 1. Let's put the vertex up here also. That was our 1, negative 9. Okay. So now, y-intercepts. Well, the y-intercepts, actually no, let's do x-intercepts first. The x-intercepts are where the graph actually crosses the x-axis. Well, the height of the graph then is 0. The y values are 0. So what we're going to do is take our equation, take our parabola, and set it equal to 0. So we'll go 0 equals x squared minus 2x minus 8. All right, well, this one factors, which I kind of like because if it factors, then it's easy to find out what it is. So I'm going to factor parentheses, parentheses. I know to make it x squared, I'll have to go x times x. I'm going to use the multiples of 8 that add up to negative 2, which is going to be a negative 4 and a positive 2. All right, so I'm trying to find the x values, and there will be 2 of them when it equals 0. So I'm just simply going to take then my 0 equals my x minus 4, and my 0 equals my x plus 2. If I do a really easy little solve, plus 4 plus 4, one answer is x equals 4. So it's a point at 4, 0, because the y value is 0 plus its next intercept. The other one, subtract 2, and I get x equals negative 2. So again, it's a point at -2, 0. All right, let's go up and graph that. So if I go up to my graph, I'm going to have an x-intercept at 4, 0, 1, 2, 3, 4, and a y0, another x-intercept at -2, 0, 1, 2, and I'll put it right there. Now, one of the things I would like is the y-intercept. Well, the y-intercept is actually pretty easy. The y-intercept, if you think about it, here looking at the graph, the y-intercept is where it's going to cross the y-axis. Well, that's where you have an x value of 0. All right, so let's define a y-intercept. We're going to let x equal 0. So I'll go y equals, plugging 0 in, 0 squared minus 2 times 0 minus 8. Oh, that's a bad looking 8. There we go. And so y is equal to -8. We kind of knew that anyway because it looks like, you know, it's in like an intercept form. So let's put that in. So it's a point at 0, -8 is my y-intercept. Let's go ahead and put that in. And then because we have a line of symmetry, we're going to have to also have another point that reflects over there. So it makes it easy. If I've got this point, I really do have this point because it's symmetrical. And there's my parabola. Just have to scratch it in. It's curvy. It is curvy. It is not pointy. There you have it. Right? Let's do this one more time. Let's turn the page and do one that is possibly upside down. Right, example 2. 2x squared minus 12x plus 15. Actually, this one's not upside down at all. We're going to see what happens on this one, okay? And determine the vertex, line of symmetry, x-intercepts, and y-intercepts, okay? So, first of all, the vertex. Let's go back. We need to use the equation x equals -b over 2a. There's my a, my b, and my c. So my vertex then can be found by taking my -b, which is my -12, over 2 times a, which is 2 times 2, gives me a 12 over 4. There's the bell again, over 12 over 4, which is 3. Okay, so we have a vertex of 3 something. So to get the corresponding y value, let's find the y value. We'll plug 3 in. I'll plug 3 in for x. I can do that. That's not too bad. Y equals a 2 times 3 squared minus 12 times 3 plus 13. Let's evaluate this. I think it's easier just to put it in the calculator. Let the calculator do the work for me. 2 times 3 squared minus 12 times 3 plus 13. And I get an answer of -5. Okay, y equals -5. So there's my vertex. 3, -5. Alright. Line of symmetry. Well, let's put down a little rough graph of this. Let me grab some graph paper. Oh, I don't have graph paper. Figures. Okay. We'll just do it by hand. We'll just do a nice, neat job by hand. So, grab a ruler. Oh, here's some graph paper. I found some. This will give you a chance to catch up on it. Alright. And straight edge as a ruler. This will work. Hopefully it's helping you catch up. And let's see what I have. So let's put down our vertex at 3, -5. 1, 2, 3, 4, 5, right? And then we know we're going to have a line of symmetry going right through the vertex, so my line of symmetry has to be x equals 3. And yes, it's always the x value of your vertex. I'll say that again. The line of symmetry is always the x value of your vertex. Okay? The line of symmetry has to be the x value of your vertex. Okay? So sketch that in. All right? Now, x-intercepts. Let's see if this factors. Now, if it doesn't factor, then we're going to have to figure some things out. So I'll get a 2x squared minus 12x plus 13, and that equals 0. Okay, will it factor? I don't know. Let me see if I can figure out if that factors, huh? So what are the multiples of 13? 13 and 1. And somehow we have to get a 12. We got to use the 2. I'm not sure if that's going to work. Give me a second to think about it. Anybody got any ideas? Doesn't work? Then we'll have to think of something else. Okay, hold on. Thinking. Is it going to work? If it doesn't work, then we're going to have to graph it. It doesn't work. So, quadratic formula, or we graph it. So let's put it on the graph. Let's go straight to y equals. We can clear that. And I'm going to teach you something about zeros. Okay? So let's go ahead and do a 2x squared subtract to 12x plus 13. Alright? I'm going to graph it. Now I've got on the website already finding zeros. Okay, so the zeros are here and here. We're going to go to calculate. We're going to look for zeros. So on my calculator, okay, remember how we did this before? I'm going to go to second calculate, but this time I want 0. Okay, there's the 0. Enter. Now there's two of them. There's the 0 right here, and there's a second 0 here. So what I'm going to do then is try and find the first one. So it's left bound. To be the left bound, really, it's going to be above the curve. If I'm looking for this 0 right here, left of it would actually be above it. So when I take the cursor, I'm going to have it above my 0. Okay, I'm going to lock it in there. Enter. Bring it down below it. Even though it says right bound it would have to be below it because I've got the left of it right. Enter. Enter. So what do you know? 1.418, or how about 1.4? So one of my zeros is about 1.4 comma 0. All right. Let's try that again. So now let's calculate the other 0. So I went second, calculate. Let's go to 0. And I need left bound. In this case, the left of it would be below the x-intercept. So I'm going to take my cursor and have it below it because that is left of it. I know it's a little confusing. Don't use the up and down arrows. Don't use the back and forth arrows. So I'm going to lock it in, enter. And then to be the right-hand bound, it really is above it because that would be right of the point. Okay, don't use your back and forth, or I'm sorry, don't use your up and down arrows, use your back and forth, enter, guess. So there it is, about a 4.6. Alright, so 1.4 is about there, and a 4.6, 4.6 is about there, okay? Alright, lastly, I can get is the y-intercept, which that's pretty easy. My y-intercept is when you let x equal 0, and obviously if you let x equal 0, then it's got to be at 13, so you're going to get point at 0, 13, which is way up here, so I'm going to fit. So let's just sketch it in. Okay. Now granted, you can do a lot of this on your calculator, I understand that, but I still want to see the work. You'll get graded on the next quiz on the amount of work you can show. If you can't show work, you won't get full credit. So if you want to go back through how to do these zeros, just rewatch the film. Okay, and that's all I have.